SANDHAN, All Gujarat Integrated Classroom.
સેટેલાઇટના માધ્યમથી જોડતી કડી એટલે સંધાન.
Hi friends, so after quite a long break we are back with Scilab. As you all might have remembered that the last lecture that we have was Scilab. We introduced you to a couple of concepts like basic algebraic operations, addition, subtraction, multiplication, complex scripts, logarithms, exponentation, vectors, and a little bit of matrices. Just a quick recap of everything. We are from IIT Bombay Spoken Tutorials, which is tutorials for free and open source softwares, me and my friend Neil, and we teach you free and open source softwares, and we encourage you to conduct these kind of workshops for free and open source softwares in your colleges. These details will give you at the end of the lecture. Let us begin. A quick recap of what is Scilab. As I said, Scilab is free and open source software which can allow you to do mathematical calculations, starting from a simplest calculator to most complex calculation in the mathematics. Today we will see some of them like matrix operations, solving linear equations and things like that. Scilab, you can call it, it is the free and open source counterpart of MATLAB. MATLAB is licensed. It is, you have to pay for purchasing MATLAB and use it. But Scilab is free and open source. In the previous lecture we did show you that how to find Scilab, go to Scilab website, download it and install it. But again, let me remind you one very important point during installation: you need internet connection. Your PC should be connected to internet for installing Scilab. That is very necessary because certain softwares, the sub softwares for installing Scilab will be downloaded online. So Scilab is a free and open source counterpart for MATLAB. As I said, you can use it for simplest mathematical calculations like 2 plus 3 equals to 5, and these can range up to most complex scripts like integration, differential equations, solving polynomials, everything. Yes, of course, if you talk of these things, that solving a linear equation, you can do it in a scientific calculator also, but then we have to accept that these calculators too have the limitations. Moreover, entering the details, the question in the calculator format in its syntax is something a bit cumbersome, and if you miss out, you can never know that there is an error unless you execute it. Calculators do have their limitations. You can't solve a differential equation in a calculator. Of course, matrices and polynomials you can solve, but not everything. So that's why softwares like Scilab, they come to your help. Scilab, you cannot even imagine that Scilab can also help you simulate your algorithms. If there are certain algorithms that you have, some pseudo code of algorithms, what we call the pseudo code, you can execute that in Scilab. So it is exactly similar to MATLAB, same functionalities, and allows you to do same things, but it is free and open source. Now, isn't that wonderful? You get all the functionalities that you get in licensed software, that too free, open source. So in previous lecture we did see the basic mathematical operations, addition, multiplication, division, subtraction. Then after we saw complex numbers, some calculations with complex numbers. If you remember, we did had the percentage I to indicate the imaginary number, percentage I for iota. Then we went to logarithmic expressions, exponentation, everything we did saw. Quickly we reviewed because those things are very simple. Log 2 will give you 0.3010 if the base is 10. So things were simple in the previous lecture. Of course, towards the end of previous lecture we went to vectors, how to insert vectors in Scilab, multiply, add, subtract vectors, the dot product and vector product of the vectors, transpose of the vectors. These things we saw. Let us extend it further. What comes after vector in mathematics? Matrices. A two-dimensional vector is called a matrix. So today we will mainly aim at teaching you matrices. some basic operations of the matrices. We may not get into addition and subtraction in detail because it's just a minus b and Scilab will do it for you. So those things are not that difficult, but yes, in the second half of the lecture we will go to solve the simultaneous linear equations using Scilab. It is very simple, you would just love it. So let's get started with the lecture. Enough of recap, and I will ask my friend Neil to start off for basic operations on matrices. Neil.
Okay, thank you Tadrash. Hello everyone, I am Neil Patel and I welcome all of you in this second session of this Scilab. And in this session basically we are going to cover the matrix operation and how to create matrices in the Scilab. Before going on that, we will first come to know that what actually the matrix is. So in the simple definition, matrix is nothing but a rectangular arrangement of the mathematical expressions. When you see a matrix, you will only see the numbers, but actually those numbers are mathematical expressions, or you can say that any expression or equation of maths you can put or you can show it as a matrix. Here for defining matrices in the Scilab, there is one convention that you have to use only capital letters as the name of the matrix. As you might remember that in the vectors we used to have the small letters to assign names to the vectors. So it is completely opposite for the matrix, only capital letters are supposed to be used. So now let us start with the matrix. Just look at the screens. Let's first start with the how to define one matrix inside the Scilab. As you all know that this is the screen of the Scilab console. Okay. When you run the Scilab, you will see the screen and one arrow will be shown at the bottom part, and next to that arrow you will see the cursor. You can start writing from their point. It's control. Okay.
Let's zoom it so you can see it better.
Okay. So let's first define one vector called one matrix called E. So to define the matrix, it should be capital E is equal to square bracket. Now you have to enter the elements of that matrix. As of now I am going to define one matrix of 2 cross 3. That means it will have 2 rows and 3 columns, so that the total number of elements would be 6. Okay. So and remember one thing also, whenever you define a vector or a matrix, the elements needed to be fed in the row column measure, okay, row measure order. So first we have to assign the elements of the first row. That would be say 5 space 19 space 15. So these three are the elements of my first row, 5, 19 and 15. You just have to put one space between two elements and Scilab will do according to that.
Or you can place a comma between elements.
Yes, comma is also allowed. Okay. After the completion of the first row's element, you have to put one semicolon. Please remember it's a semicolon, not a comma. Okay. Then I will enter the second row. It should be 8, 22, 36. That's it. My 6 elements are there. Square bracket complete. Press enter. Scilab will show you the matrix elements. Okay. In the first row it is 5, 19, 15. In the second row it is 8, 22, 36. So this is the very simple part to define one matrix. Okay. Now what I want to do, I want to extract the number 19. Okay. Where is it is actually located? In the first row and in the second column. Okay. So if I want to extract the number 19, what I simply do, my matrix name is E, then the small bracket. First you have to assign the row number in which your element resides, that is the first row, comma. in which column your number resides, that is the second element, in first row, in the second column, complete the bracket, press enter, it will show you 19. Okay, so by doing this operation you can fetch any element of any row and any column. You just have to find the intersection of that row number and column number. Okay, similarly if I want to fetch the first row, okay, so for that I will do E small bracket, the first row, column, semi-comma, then you have to put the colon sign. The colon sign will fetch all the columns for the first row. That means it will fetch column 1 that is 5, column 2 that is 19 and column 3 as 15. Okay. Oh, that should be comma, I am sorry. It should be E comma colon press enter, sorry.
Yeah, so friends, an error we made. Please make sure you don't make this error. When you define a matrix, it has to be a semicolon with separating the rows, and when you extract an element from a matrix, it has to be a comma between row and a column. So the syntax would be like matrix name, bracket open, row number, comma, column number, right? That will extract the element of that row and column, the intersection of row and column, the element will be extracted. So again, it has to be a semicolon when you're defining a matrix and a comma elsewhere. Also one more thing which Neil said, you have a colon, which means what? In you compare the syntax, it is E bracket open row number 1 comma, we haven't provided column number, it's a colon, right? Those ratio sign colon, that means all the columns. So suppose let's see if we put E bracket open colon comma 1, that means what? In place of row we have a colon, that means all rows of first column. Let's see, yeah, I have it, all the rows of first column means 2 rows of first column. So now you should be clear that colon sign is basically all, stands for all. So E all rows first column. In the previous one we had E first row all the columns. Oops, sorry. Okay, so that means colon stands for all.
Okay, now next what I want to do is that out of those 6 elements that we have defined inside the E matrix, I want to extract those 4 elements of the second and third row and first and second row. Okay, so to do so, what we have to do, we are going to extract all the row elements, that is we are going to extract the elements from each and every row, that is from the row 1 and row 2. So for that we are going to write, okay, that let's see, now I want to fetch number 19, 15, 22 and 36 only. So for that what I am going to do is, first of all I have to write E small bracket. Now as I want elements from each and every row, I will put colon over there, then comma. Now what I want, that I want the elements from column number 2 to column number 3. So for that I can put sign of 2 colon 3 bracket close. This expression will fetch elements 19, 15, 22 and 36 for you. This simply means that you have to extract all the rows, but only those elements who are in column number 2 and column number 3. Let's see what it shows. Okay, so it's 19, 15, 22, 36. Now suppose that your matrix is too much big, okay, it's very large and you do not know the exact size of your matrix.
Okay, before that, here let me give you a small exercise, you should try it out. In our matrix we extracted all the rows of column number 2 and column number 3, but suppose, see, column number 2 and column number 3 are just adjacent to each other. Suppose you want to extract the elements of all the rows of column number 1 and column number 3. So what should be the syntax like? What should be this expression like? Find it out. A small exercise for you, do it, because this is important. When solving certain equations you may need it. So a small exercise, try it out.
Okay, so what my friend Tadrash is exactly trying to say is that you have to extract these elements number 5 and 8 and number 15 and 36. You have to eliminate 19 and 22 out of this E matrix. Okay, so let's move on to that, what I was talking about, that if you do not know the size of the matrix and you want to fetch each and every element from that, okay, so for that what you can do is that simply you have to assign E bracket. I want the elements from each and every row, that's why I am putting colon in the place of row number, comma, dollar sign. Dollar sign will give the elements of the last column. Okay, dollar means the last, that means you do not know what is your matrix size, that is 2 cross 3, 3 cross 3, 4 cross 4, 5 cross 5, that you do not know, and you want to fetch the last element of that particular column or row, you can simply put dollar sign. Okay, so let's place dollar, so it will fetch the number 15 and 36 for you. Okay, okay, same thing you can do with the row also. Let's see what it shows. Dollar comma colon in the place row. Okay, so it will show you all the columns but only the last row, that is our second row having the elements 8, 22 and 36. Now next we want to find the determinant, but as you know, to find the determinant we must have a square matrix. That means it should have the same number of rows and column. So that is why we are going to assign or determine one new matrix called A. Okay, it should be equal to square bracket